All right, so now we're about to start lesson 5.3, chemistry students, and we're going to take a look at ionic compounds and their nomenclature. What does the word nomenclature mean, Mr. Hunter?
It's a fancy name, a word for naming.
So we're going to learn, first of all, how you name a cation or an anion of elements. Now, we're not going to deal with, there's some ions called polyatomics. We'll address them later.
Next, we're going to determine the ratio of cations and anions to form a compound and express this through a chemical formula.
And then we will, once we write the formula, learn to name the compound using the
IUPAC nomenclature.
Yeah, it stands for International Union of Pure and Applied Chemists. These are the people who make the rules for what we call things in chemistry.
All right.
So first of all, what we want you to write down is this definition. This is what we call the Octet Rule, and we kind of alluded to that in the last video when we were saying how atoms form ions in order to become more like a noble gas.
Yep.
So we're going to expand on that a little more. The Octet Rule basically tells us that atoms are going to be most stable and kind of in the lowest energy state when their electron configuration is like that of a noble gas, which means they have a full S sublevel, S2, and a full P sublevel, P6, in the valence energy level. And the valence level would mean what, Mr.
The outermost. We did discuss this briefly, probably last unit when we talked about shorthand notation. But the valence are the outermost electrons, the outermost energy level.
So in other words, if the S sublevel can hold 2 and the P sublevel can hold 6, that adds up to 8. So the moral of the story is an octet in the valence level is the most stable arrangement, which is what all the noble gases have. And basically atoms are going to form ions and also covalent bonds, as we're going to come to find, in order to satisfy that octet rule.
Okay. There are exceptions to this octet rule. You can probably figure it out if you look closely at the periodic table, but hydrogen and helium do not follow the octet rule as they only have a 1s2 energy level. So for them, they follow the duet rule.
That's true. So the duet rule is kind of the equivalent for very tiny atoms of the octet
with
rule.
hydrogen and helium.
Okay. Lithium, for that matter.
All right.
Beryllium, too. Okay, so when we write an ion, what do we call it? Well, for metals or for cations, Steve, yeah, it's pretty simple. So let's go back to our
use a pen
potassium ion, and we just call it potassium.
Yep, no special ending for it. It's called the potassium ion. That's all you need to know.
So for metal atoms that become ions, that's what you call them, just the same as their element name. For anions, elements that become anions, let's take chlorine, we'll make the Cl minus 1, or just Cl minus. We have to change the name slightly.
The ending goes from INE to an IDE ending. It becomes IDE. Any anion that is an element has an IDE ending. So fluorine, or oxygen in this case, oxygen becomes oxide. If you have nitrogen, it would be nitride. And then so on and so forth until all the nonmetals are named.
Okay, so pretty straightforward for naming ions. Now we're going to put it together and make some compounds and write the formula and name them.
That'll be that. So we're going to teach you how to make these things, these formula units or these ionic compounds using what is known as the crisscross method. So the first thing you have to do is find the element and put down its symbol with its charge. And we chose to do calcium, which is Ca2+, or Ca plus 2. And then we chose as well phosphide. And
so it would be the element phosphorus,
yep.
When it forms an ion, it would be phosphide.
It is in the -3 column because it is in the group 15.
So we write the ions, and the cation, which is usually the metal in these simple binary ones, always comes first. Okay, so what's next, Mr.
Well, it's called the crisscross method. So we take the charge from the one and we transplant it down to the subscript of the other, and you do that for both. So in this case, it becomes Ca with a subscript 3. You get rid of the charge, and it becomes P2. And this tells us that the ionic species is completely balanced. The charges are the same because we have 3 positive 2s, which is a positive 6, and we have 2 negative 3s, which is a negative 6. So plus 3 or plus 6 and minus 6 is the same, so we're good to go. And
so it's like a lowest common multiple problem in math, kind of.
And then the most important thing you have to look at is to make sure you can't reduce those numbers. 3 and 2 cannot be reduced.
It's a ratio. It means 3 calcium ions to 2 phosphide ions.
Yep.
And you just check it and see if you can divide a 2 out, you need to do so.
So for example, real quick, if you had, instead of calcium phosphide, if you had calcium oxide, Ca and O, where one's plus 2 and the other's minus 2, after the crisscross method, it's Ca2O2. This means you can reduce it to CaO. All right?
So the correct answer would be the most reduced form.
Yep. Alrighty, let's take a look at some practice then.
Okay, so we're going to go through and practice writing the formula. And then we're also going to name the ionic compound, which is really simple. You basically just name your cation, name your anion, that's the name of the compound when we're dealing with these simple binary ionic compounds that are just based on 2 elements in their ionic states bonded together. So we have
potassium and selenium. Potassium is a positive 1, it's in that first column. Selenium is in column 16, so it is a negative 2, or selenide in this case would be a negative 2. So it is K.
Crisscross our charges.
Yep, it's K2.
Oh, what did I do there? All right.
It's K2 SE. And
It would be an SE1, although we typically
off the
never
ones.
write ones, so we just would write K2SE.
okay. So if you want to write this out then, if you were to name it, that would be potassium selenide. All right, the next example is magnesium and oxygen. So magnesium is Mg2+, found by the periodic table. Oxide is O2-. We're not going to draw out the crisscross for you. I think you understand it. It is MgO because you have to reduce the 2's. And this becomes magnesium oxide. And then our very last example is that of lithium and phosphorus. Lithium is a +1. Phosphide is in the negative 3 column of the group 15. So it becomes Li3P1, but we don't write the 1. And that's lithium phosphide. Alrighty.
Okay, so if you're confused about how we found the charges on these things, go back to the slide where we wrote down what the charge is on, and we're finding it by which column they're on in the periodic table.
Last video, yep.
And then we're just crisscrossing. Yeah, it wasn't in this video.
last
you're right.
video.
The previous video, and it becomes pretty straightforward from there.
Okay, let's take a look at the PVQs. Alright, your first question is to name what NaCl would be written out as KBr and CaO. So that's the first thing you have to do. And then they want you to reverse this process and make lithium nitride into a chemical formula in this case. So give it a try, and we will see you tomorrow.